Jungle.
Hey guys! Welcome to our video presentation all about Apriori algorithm. Let's start with the basics. When we were going on a shopping mall, we make a list of things to buy. As Christmas Day is fast approaching, we tend to have a lot of thoughts in preparing our gifts and foods for Noche Buena.
We can finally have our picnic!
Supermarket, 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 supermarket. Let's go to the supermarket. We're going to buy some fruit. Strawberries, oranges, mangoes, peaches. Let's put fruit in the basket. Yummy! Let's go to the supermarket. We're going to buy some snacks. Chocolates, cookies, candies, bread. Let's put snacks in the basket. So sweet! Supermarket, 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 supermarket. Let's go to the supermarket. We're going to buy some toys. Dolls, airplanes, drums, balls. Let's put toys in the basket. It's fun! Let's go to the supermarket. We're going to buy some household items. Tissues, hair dryers, soaps, bags. Let's put it all in the basket. Oh, cool! Supermarket, supermarket.
In Apriori algorithm, we are tasked to analyze what items are most likely to buy or not. In a supermarket, for example, it is important for them to make an analysis which item are most likely to buy together with the other item. This, at some instances, increases the sale of the market. In executing a priori algorithm, the following concepts are to be considered. All subsets of a frequent item set must be frequent. Let us take an example. When we apply for buying new things for Christmas Day, these three appears the most frequent: clothes, cell phones, and grocery items. Clothes are best buy for children under 10 years of age, because they are more likely to note the concept that every Christmas there should always be a new pair of clothes for Christmas parties. Cell phones, on the other hand, are more likely to buy by teenagers because they are more likely connected to gadgets, and buying cell phones every year seems a blessing to them, like there's nothing to ask for more. And last, groceries, of course, best suits our mothers, for they are the ones responsible for preparing foods and desserts for Christmas Eve. Let us take clothes as a variable A, cell phones as B, and groceries as C. Now, we have 5 transactions here labeled 1 to 5. These transactions pertain to the different persons per family who buys new items for Christmas Day last 2016. So, our analysis will be dealing with which items are most likely to buy for this 2017. On the first transaction, evident that all the three items are bought altogether. On the second transaction, only the grocery items are bought, which seems the family values food than any other things. On the third transaction, A and C, which symbolizes clothes and groceries, are being bought together. On the first transaction, the same items are bought with the transaction number 3. And last, on the fifth transaction, clothes and gadgets are bought for Christmas. In the analysis of which items are existent, we use various measures such as support, confidence, lift, and conviction. The first one is support. Support is an indication of how frequently the item set appears in the dataset. By calculating the support in a given transaction, we get the ratio between the number of transactions in which X appears and the numbers of transactions. In an example here, the support of clothes equals the number of transactions in which clothes appears as seen in the transaction is counted as 4, divided by the number of transactions, which is 5. We will get the ratio between them and we got 0.80. Next, we are going to determine the confidence of the transaction. Confidence is an indication of how often the rule has been found to be true. It is given by the formula confidence of X implies Y equals the support of X union Y divided by the support of X. For example, calculating of the confidence of X implies Y. We have the support of clothes union cell phones that is given by 2/5 as stated in the earlier discussion, and the support of clothes, which we have calculated earlier, have a ratio of 4/5. This gives us 0.5 as the ratio for confidence. One drawback of the confidence measure is that it might misinterpret the importance of an association. This is because it only accounts for how popular clothes are, but not cell phones. To account for the base popularity of both constituent items, we will use the third measure called as lift. Another important measure is lift. It shows how likely item Y is purchased when X is purchased, while controlling for how popular item Y is. For computing for the lift of X implies Y, we have the formula given by the ratio of the support of X union Y and the support of X multiplied by Y. In our example here, we have the value of the support of X union Y that is 2/5. The support of X that is 4/5 multiplied by the support of Y that is 2/5 gives us the product of 1.25. If the lift value is greater than 1, Y is likely to be bought with X. But if the lift value is less than 1, Y is unlikely to be bought when X is bought. So therefore, in our analysis, we can say that cell phone is likely to be bought when clothes are bought. The last measure is called conviction. We can get the value of the conviction of X implies Y by dividing 1 minus the support of X union Y over 1 minus the confidence of X implies Y. In the example given below, the conviction of clothes implies cell phones is 1 minus support of X union Y. That is 2/5 divided by 1 minus the confidence of X implies Y. That is 0.5 gives us a ratio of 1.2. If you discover that sales of items beyond a certain proportion tend to have a significant impact on your profits, you might consider using the proportion as your support threshold. In our analysis, we will use a 50% threshold. This means that when we compute for the number of frequencies of each item set, we will eliminate those who do not exceed the assigned limitations of 50%. By calculating the 50% of 5, since we have 5 transactions, we have 2.5 or 3. By doing the analysis, we have 4 steps to be followed. Step number 1. We will make a table for the items and their frequencies on the 5 transactions that we make. We can see that item A has 4 frequencies. A sudden decrease of 50% for item B, which has only 2 frequencies, and item C. The same with item A, has also the same number of frequencies, that is 4. Step number 2. We will eliminate items that do not reach the support threshold. That is item B, because it appears only twice in the transaction. Step number 3. We will make a 2-item set. This means that we will make a table for every possibility that each item will be joined by the other. We have the formula for finding this. N factorial over R factorial times the quantity N minus R factorial. N represents the number of items and R represents the number of items set that we will make. By computation, we have 3 as the number of pairs: AB, AC, and BC. Step number 4. We will eliminate the item set that do not exceed the support threshold. That are item sets AB and BC, and we have AC. Now, let's move on to the advantages and disadvantages of a priori algorithm. These are some of the advantages of a priori. First, it uses a large item set of property. Second, it can easily be parallelized. And last, it is easy to implement. On the other hand, here are some of the disadvantages of a priori algorithm. First is that it assumes transaction database, and lastly, it requires many database scans. And that ends up our discussion. I hope you guys learned a lot in our tutorial.